Hey everybody, we are back for our next lesson in systems of equations. We're still working with two equations. We have some equations graphed here for, I pre-did the first step of the problem for our first example here. And the reason I did that is because I wanted to show you how sometimes it can get a little messy with solving for y like we have been, where we subtract x from both sides or whatever the coefficient in x is from both sides of the equation, and then we end up solving, right? And we end up in this case with something like y equals 1/2 x plus 5/2. And I know that, like, as a math 1 or algebra 1 student, like getting a fraction in your y-intercept can sometimes be confusing. And in the next one, we also see another fraction in the y-intercept, and this one's probably even more confusing than the last one if you struggle with fractions. So I did graph it over here. If you want to take a second to get your graph down, I'm okay with that. Or if you just want to graph the 2 points here, or the 2 lines here, I'm okay with that. If not, in the notes, I'm not going to be grading this. The whole point of this section is to show that sometimes graphing isn't the best method. And sometimes it is. But in this case, I think with the fractions and all the negatives that we have to deal with throughout solving this one, it may not be the easiest way to do it. And there is an easier way, luckily. And the method that we're going to be talking about is linear combination and elimination. It's known by both of them. So combination or elimination. And it has to do with combining two equations together. So once you combine the two equations together, you start looking for zeros. I always say the most important numbers in math are 0 and 1. And so let's get started over here. So if you look at our equation, we can see that we have 2x minus 4y equals -10. And then our second one is 3x plus 4y equals 5. And again, over here, I solved them for y. I show how to do that. I don't really want to go into that. But what I do want to show you is that there's a -4 here and a +4. So we have -4y and +4y. Well, what is -4 plus +4? It's 0. So if we combine our equations here, okay, if we combine our two equations here, we can actually get rid of the y and combine the two x's. So 2 plus 3 is 5x. -4 plus 4 is 0. It's gone. And then -10 plus 5 is -5. So we got rid of a y. Now we divide by 5, and we have x equals -1. Okay, so we know that x is -1. We're ready to substitute -1 back into another equation, either one of the equations. I'm going to pick the second one because I don't see any negatives in it, and I don't want to deal with very many negatives if I don't have to. So I'm going to bring 3x plus 4y down. I'm going to rewrite that equation, okay, down here. I'm just rewriting it, right? And I'm going to leave a little space open, and I'm going to substitute in for x. Okay, I'm going to substitute that -1. And we have 3 times -1 is -3, plus 4y equals 5. Add 3 to both sides. Okay, and it has 4y equals 8. Divide by 4, divide by 4, y equals 2. So don't forget, you do need to write it as an ordered pair. So our x is -1, our y is 2, and there's our answer. And we can also see on our graph over here, where they cross is indeed -1, +2, okay, which is fantastic. So we're going to go through, I'm going to do probably 2 more of these problems, 2 or 3 more of these problems to show you guys exactly how to do it. But once I think you start looking for those zeros, looking for how to make something a 0, it gets a little bit easier, okay? So let's go on to number 2. So number 2, really similar problem. We're combining them together. We can just add the two equations together. So I look at 12 and 8, okay, and that adds to be 20. Negative 2 plus 2. Oh, there's our 0. Okay, we want that 0 in there. So y is gone. It won't always be y. Sometimes it will. Sometimes it won't. And then our last one is 4x plus 5x is, I'm sorry, 4x plus x is 5x. Okay, divide by 5. Divide by 5. You got x equals 4. Okay, so our first step really is to look for 0 and combine. Okay, look for the 0. Okay, that's what we're talking about here. Look for the 0, combine, and then our last one, you need to substitute back in, or solve, let's say solve, and then substitute back in. I'm going to abbreviate that. Sub back in. Okay, so we can take our x value and substitute back in. I'm going to put it in the second one. I'm going to bring this equation down. And we've got 4. I'm just going to start replacing that x since it's 4 plus 2y equals 8. So this 8 is this 8. 2y is 2y. X is now 4. We know what it is. So we can just keep it that way. So subtract 4 from both sides. Excuse me, I'm a little sick today, so forgive me if I sound more nasally than normal. And then subtract 4 from both sides. 8 minus 4 is 4. Bring the 2y down. Divide by 2. Divide by 2. Y equals 2. So almost done. You've got 4, 2 as your ordered pair. You're done. Okay? All right. So we're getting there. So our next one. The next one's a little bit different though. Remember how I said look for the 0? If we're over here and we try to combine, I don't see a 0. I don't see 5 and negative 1. I don't see a 0. 2 plus 2 is not 0. 3 plus x is not 0. But what we can do is actually multiply an entire equation by negative 1 to change it, because 2 minus 2 would be 0. But we need to multiply the entire equation by negative 1 to get our 0. So I'm going to say 3x plus 2y. I'm just rewriting this one. We didn't do anything to it. The next one, we're going to multiply it by negative 1. And that just means you're changing all the signs. So this is now negative x. This is now negative 2y. And this is positive 1. So negative 1 times x is negative x. Negative 1 times 2, negative 2. Negative 1 times negative 1, positive 1. Well, now I have my 0. So I combine these guys together. And I've got 4x. Oops, sorry, not 4x. 2x, forgive me. This is 0, it's gone. And 5 plus 1 is 6. Divide by 2. X equals 3. Okay, so we know x equals 3. I'm going to pick one of my original equations. I'll pick this guy up here. 3 times x, we know that x is 3, plus 2y equals 5. So again, I'm just pulling everything down. 5 is 5, 2y is 2y, 3x is now 3 times 3 because this is x. So we have 9 plus 2y equals 5. Subtract 9 from each side. We've got 2y equals negative 4. 5 minus 9 is negative 4. Divide by 2. Y equals negative 2. So we've got 3, negative 2. Okay. All right, so let's back up. It says, how do we make question 3 look like number 1 and 2? That's confusing to me. How do we make question 3 like number 1 and 2? They're talking about question number 2 and question number 1, right? So they're saying, well, this question is really saying, why is it that we can make a 0 here without having to do anything extra? And why is it that we can make a 0 here without having to do extra, but here we have to multiply by negative 1? Okay, well, the answer is that 2y plus 2y is not 0. Okay, we need two y minus 2y. Okay, and so you have to multiply that entire equation by -1. All right, let's go through two more examples because these are kind of weirder examples, but they're, I think, really useful for helping you guys out. Okay, so we look here. Oh, I see a 0 there. Fantastic. We don't have to multiply anything. We're getting rid of 1. So -4 plus 4 is 0. Wait a minute. -2 plus 2 is also 0. And then 4 minus 4 is 0. So 0 equals 0. And this statement is true. So that means that these are actually the same line, which means that it has infinite number of solutions. Okay, so our last one here. So again, it's kind of like 3 and 5 match up that we're going to have to multiply one because x plus x is not 0, y plus y is not 0, so we need to multiply either equation. It doesn't matter if you multiply the first one or the second one. You got to pick one. I'm going to pick the second one to multiply by -1. You got to multiply everything. So this is going to be -x minus y equals -4. And then our top one is x plus y equals -2. We didn't have to do anything to that one. And if we combine, oh, I have my 0 there. Fantastic. That is 0. This is also 0. Looks like we're running into another weird one. And then we've got -6. Well, does 0 equal -6? The answer, of course, is false. So if you come up with a false answer when we're talking about systems of equations, that means there's no solutions. Okay, no solutions. So if it's false, no solution. If it's true, infinite solutions. If you see a 0 to start with, combine them and you can go combine them and then substitute back in. If you don't see a 0, you need to multiply the second equation by -1 or a number to get it to equal 0, okay? So good luck with you guys. If you have questions, make sure you're asking them in class.